Numerical number 18 of chapter 1, electric charge and field. At each four corners of square of side A, a charge plus q is placed freely. What charge should be placed at the center of square so that whole system will be in equilibrium? Now to solve this numerical, first of all let us draw a diagram. Here you can see a square, side of square is A and all positive charges are at the corner, and we have to determine what should be the charge at the center. So that first we need to determine the equilibrium force or final net force due to all these four charges at any one point. So here first of all determine the distance between each other. So AB, BC, CD, DA all are A. RAB, RBC, RCD, RDA is A. Charges are same, let us have Q, and RBD and RAC is equals to root 2A. We can determine this value with the help of Pythagoras theorem. Now first let us have force on A due to B, that will be given by FAB K QA QB upon RAB square. That is, by substituting the values we will get FAB is equals to KQ square upon A square. Furthermore, force on A due to C will be given by FAC K QA QC upon RAC square, that is K Q square upon 2A square, because the distance RAC is root 2A whole square. Now for equilibrium, the charge Q, let us have capital Q placed at O, so that force on A due to charge Q is FAO is equals to K QA QD upon RAD square, that is K Q capital Q upon root 2 by 2A whole square, because OA is equals to AC by 2. So FAO is equals to K Q capital Q upon A square by 2. Let it be equation number 3. Now force on A due to D will be given by FAD K QA QD upon RAD square, that is again KQ square upon A square. Now resultant force on A due to B and D. Here we can see in the diagram angle between B and D is 90 degrees, so cos theta will be 0. So FAD plus FAB square, here the third term of cos theta will be 0. So net force on A due to B and D is root 2F. Similarly, for at equilibrium at A, here you can see the diagram. Here force FAO, because if the charge is negative then only we can achieve an equilibrium, so it is towards the center O, and FA, because it is a resultant force between A and D, it is outward direction. So FA plus FAO plus FAC is equals to 0, then only we can say the system is in equilibrium. So FA is equals to root 2F, FAD is equals to 2KQ into capital Q upon A square plus 1 by 2 KQ square by A square. This we have already solved by using this formula, and after solving this we will get root 2 into Q plus 2 into capital Q, Q by 2 is equals to 0. All the common terms are taken as a common and it will be 0. So after solving this we will get, let us take Q by 2 and root 2 by Q is on the other hand side. So 2Q is equals to minus root 2 plus 1 by 2Q, and let us have 2 also in the opposite side. So capital Q is equals to minus Q upon 4 root 2 plus 1. This is a solution of a numerical.